energy analysis building model now. So we're now talking about a detailed model of your building, a full BIM model. Further references, as usual, there's some supplementary videos here which you can watch in your own time. Just give a little bit more depth, cover a few more tips and skills if you're interested. Okay. Back into Revit. And I've now opened up the sample file that you have on Mole, which is called the Sample University Building on Site Energy Enabled 2016. So this is now a detailed building model. So in terms of your assignment, you're imagining now that the design has progressed in the office. You've chosen a kind of a shape for that building, a location, and that's now been developed to a level of detail. So here is the building. If I just zoom out a bit, there's the Arts Tower, there's the building, and if we look in our project browser on the left-hand side over here, because this is now a detailed building, if you look in the floor plans, for example, this is quite a detailed architectural model. It's got walls, it's got doors, it's got windows, it's got stairs. We looked before at the sections. So if you double click on a section marker, that will bring you to a section. So there's a section through our building. Okay. Should have elevations of the building. So there's an elevation which needs cropping actually. So there's a kind of simple elevation. So the first thing you can do is open this file and just start to have a little play with it. Okay? Don't worry about breaking it. You can always just download it again. Get the file, get in there, start selecting things, start deleting them, start changing things, just muck about with the model and get a feel for playing with the real kind of building model. Okay? Make new plans, make new sections, drag the walls, just have a little look at that. Okay, but for our purposes, I'm just going to shut all of this down. For today, we just want to now look at an energy simulation of that building. Now, again, these are really quite powerful tools. Because we're focusing on integrated simulation in this module, what we're not doing now is kind of exporting this model into another package. We'll perform that simulation here in Revit quite quickly. And it's very similar to what we've just done at a conceptual level, but now we're going to perform this on a more detailed building level. So, as before, let's go to our Analyze tab and our energy settings. And it's exactly the same that we looked at before. Few things that we might just want to change and make slightly different. So the first one is export category, rooms or spaces. Now I would suggest for this model leave it as rooms, because this model is created with rooms. Spaces is slightly different, where you can create energy spaces which are not necessarily the same as a room. But for now, leave it as rooms. The other thing you might want to consider changing is here, include thermal properties. Now, what that means is, if you don't include thermal properties, then Revit will use the kind of default construction types for your walls, for your windows, for your roofs, and it will pull from those default construction types the thermal properties of the materials. Now, if you've modelled your building with complex walls, you can include those thermal properties, and therefore any changes you make to the materials of your model will be reflected in the simulation. So I'm going to leave it checked, include thermal properties, because I'll show you, I have made this model with some wall properties. So if I just zoom in here, if we select that wall, and we go to our properties over here, it's called Basic Wall Cavity Rain Screen. If we click on Edit Type, we can now interrogate the build-up of that wall. And we've got lots of different settings here which we don't really need to worry too much about, but we certainly have got thermal properties assigned to that wall. If we edit the structure of the wall, what it's made of, I mean, you don't really need to get into this level of depth, but just to show you what's there, this wall is made of terracotta rain screen, there's an air gap, 100 millimeters of insulation. We can then interrogate that insulation. So rigid insulation. If we go over to the far right tab, thermal, we've got all the detailed properties of that material. Now, you would not be inserting these properties yourself, okay? If you asked me what's the permeability of rigid insulation, I would not have a clue, okay? That's not how it works. You either use default materials that have already been created, or you bring in manufacturer information in Revit. And that's the kind of the whole point about BIM really, is that when you're making an element, you make it out of real materials. So I did not insert these figures. I just picked the rigid insulation from Revit that already has the thermal properties built in. If you were, let's come out of that. If later on in the year you do want to get into more detail about materials, you can start to customize your materials. Okay. Let's just go back into our energy settings. So we talked about the thermal properties, and you'll notice now that things like target percentage glazing, target sill height, shading depth, this is all greyed out because we're not working with conceptual massing anymore. So we've got real windows, so we don't need to use those sort of rough figures. And then, as before, operation schedule, HVAC system, outdoor air information, all the same as before. Okay, so we're almost ready to go. So bearing in mind that what you see on the screen is what will be used in your results page, just put that view to a good view. And the next thing we need to do is this top button, Show Energy Model. If you try and run the simulation before that, it won't work. So we click on that. You get a little warning, you're about to create the building element energy analytical model. This may take some time. Okay? Create the energy analytical model. It'll just take a few minutes, I think. Okay, it just took a few seconds actually. Right. So it's complete. Question is, do you want to run the simulation now, or do you want to do it later? I'm just going to say we'll do it later, and I just want to continue working for now. Okay, so it's created the energy model, but I haven't sent it for simulation yet. Now, by energy model, what do we mean? I'm going to zoom in a bit here. this is the graphic view of our energy model. Now, an energy model is only really interested in spaces, the materials that enclose those spaces, and shading. So it's not really, it's not really terribly interested in furniture or what colour that is or anything like that. And what you're viewing now is really the kind of information that will be sent for analysis. Now you can customize this view. The first thing to note is when you first create this, by default the masses will be switched off. So VV, scroll down, mass. It can catch you out a little bit because by default that will be switched off, and when you create your energy model it will look like this, which can be a little bit surprising. So we'll just switch those back on again. Okay, just zoom in a bit. Okay, if we go back VV, we've also got analytical model categories across the top, and by default analytical spaces and analytical surfaces are switched on in the view. If we switch off the surfaces, then that sometimes just makes things a little bit clearer to understand. But in any case, this is not really something that you're going to be amending. It's just to give you a kind of graphical view of your energy model. Right. So we're all ready to go, really. Let's just zoom out a bit there. So, as before, we're going to run the energy simulation up here. Yeah, it's asking us, do you want to use the existing energy model or do you want to update it? Now all it's saying there is you created the energy model but you didn't send it. If you've gone back and made any changes to the design, do you want to update the energy model? Now we didn't make any changes, so I'm just going to use the existing. Yeah, just a little warning. Not really telling you very much there. If you click on the link to learn more here, there's a little bit of extra guidance. Okay. Okay, interface that we were familiar with. And what I'm going to do now is, what I should have done last time, is use an existing project. So we'll pick our University of Sheffield Plaza Hub, and it will put it in the right place this time. And we need to give that, that run a name. So I'm going to call this one, now I can't remember if this is option D, but let's just call it option D. I normally put in the name building level analysis, just to distinguish it from the conceptual. So we've given it a name. We've got some options there, which I'm not going to change. Okay, click continue. Hopefully there's no problem this time. So if you look in the bottom left, you get a progress bar. Oops. So yeah, so it's gone. So it's sent that off now to Autodesk. If we now go back to our results and compare, let's have a look. So here it is, option D, building level analysis, 0%. So it's busy calculating, and I guess this will take a bit longer because it's a building level analysis, but I did run a few last night. So let's have a look here at option D. So this was the one that I sent through last night, which is a building level energy analysis. And I won't go in detail here about all of the results because we've covered that. But again, this is very powerful because you can compare, for example, we could compare two different options, one of which might be a conceptual model, one of which might be a full building model. And we can compare those two results. We could, that one's almost finished, isn't it? We can compare more than two. So we can compare as many as we want. You can compare two different building level analysis studies, and really the sort of the level of analysis is then in your hands. So you might, for example, compare very different shaped buildings. You might compare the same shaped building, but one you might orientate north-south, one of them you might orientate east-west, and simply look at the energy performance. You might look at very kind of detailed comparisons. So for example, if we go back into Revit, if I go back to our 3D view, you might oh yeah, let me show you something here as well actually. What I forgot to show you earlier, when you create the energy model, Revit will, it automatically creates you these 3D views. This is new in Revit 2016. So as soon as you create the energy model, it creates you these views, which can be useful. But what I was going to say was, at a detailed building level, it could be that you want to compare some very kind of precise design changes. So for example, you might want to just compare, let's say, what happens if I delete that window? And you know, that might be quite a small design change, and you could then retest that. You might look at, for example, different shading configurations and test the energy performance of that. Let's go back into our results. Okay, so we've finished. There's our building level analysis, and there's our full set of results. Okay, we'll stop there in just a minute. So really, I've shown you the kind of skills to run this analysis now. What you should do is have a look at some of the example reports from previous years, and look at how the students have used these skills to compare these designs. And then in your assignment, what I'm looking for really is for you not just to understand the skills to run the simulation, but to demonstrate the ability to integrate that into a design process. So show me that you can compare different design options, look at the results, and make decisions and make recommendations on that basis. Okay. The other thing I think to bear in mind, which sometimes students can get a little bit wrong, is we're concerned in this module at comparing energy performance, but obviously a building is much more than just energy performance. So there's not much point comparing options which you would never want to build. And we've had a few odd ones over the years where students, for example, placed buildings right in front of the entrance to the Arts Tower and tested it. And you know, I can see what they're thinking is they're interested in the effect of shading, putting two buildings close together. But then you look at it and say, but you would never build a building across the entrance to the Arts Tower. You know, it just doesn't make any sense in terms of circulation or appearance. So, you know, I think it's sometimes you can get a bit preoccupied with the energy analysis and sort of forget the other decisions. And it's quite acceptable in your report to, for example, discount certain design options. So I think one student, for example, one year, they said, look, I'm not going to let this building go any higher than 3 stories because I don't want it to kind of dominate this site. So although they may have found that by going higher maybe there were energy benefits, they said, no, I'm not doing that. Another student was kind of very keen that the building should be a rectangular shape. So they didn't try anything other than rectangular shapes. Some of the examples you'll see students compare very kind of complex shapes, but I'm not sure that they really understand why they're doing that. Okay, for this site. Now the next session we're going to look at some much more complex conceptual massing, creating very complex shapes, which for some sites would be appropriate, but probably for this site is probably not so necessary.